Bienvenidos, Ushamdi, and welcome CTS-131, Section 875 students for the Spring 2018 semester at Anne Arundel Community College. This is the Routing and Switching Essentials version 6 course, and this afternoon's Packet Tracer tutorial and solution set is going to be on Packet Tracer Activity 2.2.2.4, where we're going to be taking our first look at IPv4 static and default routes. In fact, if I'm not mistaken, we're actually going to be creating some recursive routes as well. So let's go ahead and dive into the activity here. We have our topology on the left. It looks like we've got 5 different networks. And then we've got our instructions or objectives and scenarios over here on the right, along with the addressing table. So let's go ahead and dive in, and I'm going to touch on some of the questions that have been coming up during the week that have been sent to me, and so that way everyone in the course has an idea as to what some of the other students are thinking. Now, in this activity, we're going to configure static and default routes. What do we got? We're going to do a recursive static route, directly attached static route, and then a fully specified static route, and then a default route. So there's multiple ways that we can go about this. Now, look at the topology diagram. How many networks are there in total? Well, this is a pretty straightforward question here, right? We've got 1, 2, 3, and then we have these 2 networks here, 4 and 5. Now, both of those networks are commonly referred to as transit networks. And the reason that they're referred to as transit networks is that their sole existence is to provide transit for the data traffic, right? So PC3 pings PC2, or PC1 SSHs over to PC3. All of that traffic between the PCs is going to transit these links. So in other words, these aren't links where you have hosts like PCs and servers and access points. They're simply there to facilitate the transit or transfer of the traffic. So looking at the topology diagram, I see 5. How many networks are directly connected to routers 1, 2, and 3? Well, we've got those are directly connected, right? And then each router has that network segment behind it to which it's connected. So how many networks are directly connected to 1? So 1 is connected to 2. 2 is actually connected to 1, 2, 3, and then 3 is connected to 2. So how many static routes are required by each router to reach networks that are not directly connected? Now, this could be, you can think of it as maybe a trick question, right? Because you might be thinking, for router 1, right, all router 1 knows about is that network segment and this network segment. Router 1 knows nothing of that network segment right there. And he knows nothing about, actually he knows nothing about this network segment here and that network segment there. So again, it's only to what router 1 is directly connected that router 1 knows how to reach. So 1 can reach router 2, but he can only reach it on that interface. All these other interfaces here behind router 2, in other words, this interface and that interface right there, think of it as like there's this, and this is my very poor artistic representation of a curtain, right? Is that router 1 can't see behind or beyond the router 2 curtain, right? So router 2 is sitting behind the curtain, or I mean, all the networks behind router 2 are sitting behind the curtain, and router 1 doesn't know how to get there. 1 could ping 2, but only on this interface. So if we put a static route here on 1 that said to get to that network, go to router 2, what would the problem then be? Exactly, it would be the exact same issue in the opposite direction, is that let's say we send a ping. So PC1 sends a ping and we have a static route on router 1 that says to get to the 172.31.0.0/24, go to router 2. Well, that traffic is going to get up here. It's going to hit the PC. PC2 is going to send an ICMP reply to the destination IP address, which is PC1, and that packet is going to come right back here to router 2, and router 2 is going to say, I have no idea how to get over here to this network segment, because router 2 knows about that network segment, this network segment, and that network segment, and that is it. Those subnets right there, that's all router 2 knows about. He doesn't know about this network here. So we would need a second static route, and it could be a recursive static route, it could be a directly attached static route, and it could be what happens when you combine a recursive and a directly attached, a fully specified static route, right? So we need 2. How many static routes? So it's going to be 2. Now, test connectivity to the R2 and R3 LANs, and so very fortuitous here, we're going to do exactly what we were just talking about. And not having looked at router 1, my guess is going to be that this is not going to work, because I'm assuming they're going to want us to create these static routes. So when I ping 172.31.0.254, that is PC2, router 1 is going to say, hey, whoa, destination host unreachable. Again, this is a reply that we are getting back from router 1, because what happens is when this ping packet gets sent, and let's draw out a little picture here. When the ping packet gets sent, you've got this guy or gal over here at the PC, right? And they run the ping command. Whoops, boy, oh boy. They run the ping command, and they send the ping traffic, and they want it to go up here to PC2. However, when the IP packet, right? Because remember, there's going to be a layer 3 packet. Actually, let me back up a step here. So the user here types in ping 172.31.0.254. PC1 looks at the networks that it knows about. And PC1 says, yeah, hey, I know about that network right there because it's configured, because I have an IP on this network, and I have a subnet mask configured on this network. But I don't know about that network. And so what does PC1 do with the traffic? Exactly. He says, I don't have a network that I know about in my network table, so I don't know how to get here. But I'm configured with a default gateway, right? And that is my safety net. So that if I don't know how to get to a specific network, I simply throw the traffic over the fence. And the fence, you can think of the fence as being switch 1 here. I throw it over the fence and say, hey, router 1, you're my default gateway. You get me to where I'm going. And so when that packet shows up here, the IP header has a source and a destination IP, right? The source is going to be PC1, and the destination address in that header will be PC2's IP address, not the host names, the IPs. Remember, we're dealing with the Internet Protocol here. Nothing to do with DNS right now. So we have a source IP, which is PC1, and a destination IP. And router 1 looks at that, and he says, hey, thank you so much for sending me that traffic, PC1. Now I'm going to consult my routing information database. Now, that's the technical name for what you know as the routing table, or the RIB. The RIB is in boy. It stands for Routing Information Database. And again, it's just your routing table. And the command that we use to see that is show IP route. So router 1 gets this traffic that's been thrown over the fence from PC1, because PC1 has no clue how to get to that network. All he knows is, hey, I've got a default gateway. I'm giving it to that guy. And that guy is router 1. Router 1 says, all right, what is the destination network that you're trying to get to? And router 1 sees it's 172.31.0, or it's destination IP, 172.31.0.254. So router 1 consults his routing table. And he says, do I have an entry to get to 172.31.0.254? Do I know how to get to that IP? Do I have an entry that tells me this is where you go? And on router 1, it could be a recursive static route. It could be a directly attached static route. In fact, on router 1, it could be a default route, right? Because from this perspective, right, from looking at this network here, how many ways can PC1 get traffic over here to PC2 and PC3? There's only one way out. You'll notice there's no link here, right? Now, this brings up other questions that we will get to down the road in the course, but that link isn't there. So a default route would work on router 1, where basically router 1 is going to then behave just like the PC did. When the PC said ping 172.31.0.254, and it consulted its network table, and it said, yeah, I don't know how to get there, but I have a default gateway. I'm just going to send it there. And so then the traffic shows up here at router 1. And right now, router 1 looks at its routing table and says, I don't know how to get there. So we could put a default route that basically said, yeah, just send it to router 2. Maybe router 2 knows how to get there. Now, that's the process that takes place. Let's take a look and see, since we know we're getting this destination unreachable, and again, this is router 1 saying, hey, PC1, I consulted my routing table. Dude, I am really sorry. I don't know how to get there. In other words, the destination host that you were trying to reach, I cannot reach it. It is unreachable. So, and 3 is going to do the same thing as my guess. Let's go ahead and for completeness here, we're going to say ping 172.31.1.190. And again, destination host unreachable. And that is an ICMP reply that you will get back, or an ICMP packet that you will get back that indicates that the router or a router along the path does not know how to get to where the packet is trying to go. So why were you unsuccessful? We kind of beat this one pretty good, is that router 1 doesn't know how to get there. It's as simple as that. Router 1 has no clue how to get to those networks. So now let's go ahead and transition over here to part number 2, where we're going to configure some static and default routes. Now, this was a great question asked by Lauren a couple days ago. She was confused about what is a recursive static route. What makes a static route recursive? What makes it directly connected? What makes it a combination of the two when it's fully qualified? So here's the idea behind a recursive static route. Let me pull router 1 up, and let's get some space here with which to work. All right, so when we go to the command line interface on router 1, and we go from user exec as evidenced by the greater than sign, we issue the enable command to get into privilege exec mode, where we can make our configuration, or we can make configuration changes, but ultimately we're going to get into global config to do that. So we're in privilege exec. So how do I see the routing table on a router? I say show IP route. And so what does router 1 know about? And we kind of suspected this, right? Because it certainly doesn't know about any of these networks that it's not directly connected to. And so a recursive static route is a route that has to do 2 lookups in the routing table to figure out where to go. So you can see here that I know that I'm directly connected to router 2 via the serial 000 interface. And so I know about the directly connected network segment. I can ping router 2, right? I can ping the before I say I can ping router 2, let me make sure I'm specific here. I can ping this interface on router 2, right? Do you think that I can ping that interface on router 2? Well, let's give it a try. Let's see what happens here. So let me first ping the first interface, which is 172.31.1. And my bet is it's 193. And I can, let me double check. I want to make sure I didn't just ping my own interface here. So 190, yeah, 193, and I'm 194. Okay. So router 2 is 193. So as you can see there, works like a champ, right? Because router 1 is directly connected and knows how to get to an IP address that lives in this little subnet right here, this /30, that only has 2 usable IP addresses. Let's ping over on the other side, see what happens. So we're going to say ping 172.31.1. And I have to look again. Let's do router, not router 3, router 2's 197 is the IP. So we want 197. Why does that not work? Because I know how to get to router 2. So shouldn't router 2 then know how to get back to me, router 1? He should, but it doesn't work, right? It doesn't work. So let's go ahead. We're going to refocus. I just want to make sure I showed you that. So let's do this. So where are we at? Recursive static route. So a recursive static route is a route in the routing table that has to do 2 lookups. And here's how you create a recursive static route. And if you're thinking that recursive sounds bad, it does, because it forces the router to do 2 lookups. So we're going to do configure terminal, or conf t, to get into global config mode. Why does it require 2 routing table lookups? Well, we're going to see that. Configure a recursive static route to every network. So there's going to be 3 total that are not directly connected to router 1, including the WAN link, that transit link right here. So let's do these first 2 that we can see, and then I'll have to move out of the way because I can't remember what the other one is there. So IP route. Now, here's how I think of it in English, and this is try to get yourself into this habit of saying, my IP route to get to the 172.31.0.0. Now, I wish you could say /24, but you can't. You're going to have to do the dotted decimal notation here for the subnet mask. So my IP route to get to the 172.31.0.0/24, or the 255.255.255.0, is going to be to go to the next hop IP address, 172.31.1.193. In other words, I'm instructing router 1 that for any traffic that shows up with a destination IP address in that subnet, which PC2's IP is in that subnet, you're going to send that traffic to 172.31.1.193. Now, that's all fine and dandy. However, what does router 1, with this entry right here, what information is missing? What is it that router 1 also needs to know? Because router 1 could have many interfaces, right? So let's take a look at the routing table now by saying do show IP route. And that do command, and I apologize if I haven't explained this before, but that do command allows us to run commands that we wouldn't be able to run in global config. It allows us to do it as if we were in privilege exec mode. So I say do show IP route, and here's the routing table now. So again, this is great. We've got this static route here, right? And that's fantastic. I think that's great. However, what else is needed in addition to knowing the next hop IP address when router 1 is creating the packet, right, and then entering in the layer 2 information? It needs to know the outgoing interface. It needs to know the directly connected interface. And so this is your oops, sorry, I don't want to do that. This is your recursive entry. Because here's what happens now. So, and I should probably, let's drop this window down. Whoops, drop this a little bit down here so that we're there. Yeah, so we can see the PCs in the router. So when PC1 now says ping 172.31.0.254, the ping packet gets here to router 1, because PC1 looked in its network table and said, not going to work. I don't know how to get there, but I've got a default route, and I'm going to send it to the default route, or the default gateway, sorry. And the default gateway happens to be router 1. So router 1 gets the packet. It looks at the source and it looks at the destination, right? It looks at the destination field in the IP header, and it says, hey, this is going to somebody on that network segment. And it says, oh, this is awesome. I know how to get there. And it's via this IP address. However, I now need to figure out which interface is this network living. Where does it reside? What interface is this network on? So it looks in the routing table one time, and I should have probably cleared there. I didn't give myself enough. Oops, didn't want to scoot that up. I wanted to scooch this up a little bit. And let me clear out here real quick. So it looks in the routing table, and it says, yeah, this is awesome. I know the next hop IP address. So here's lookup number 1. And then it says, but I need to know the outgoing interface. So what interface do I have, and I better have it, that is directly connected that this network sits in? And now I know. So the packet shows up, the first lookup comes in here, and then the second lookup to get the outgoing interface is the recursive lookup. In other words, this is not good enough. I need to know the outgoing interface so the router can properly construct the layer 2 and layer 3 information so that it can forward it out the correct interface. That is a recursive static route, and that is what we've just created. Which command only displays the static routes listed in the routing table? What do you think? Show IP route, and I'll do it from show IP route, show IP route, question mark, and static, right? So there's the static route, and that is our static recursive route. And did I miss something here? Why does recursive, okay, we talked about why, okay, we talked about what is a recursive static route. You should be clear on why it has to do 2 lookups, right? Because the next hop IP, that's great, but I need to know the outgoing interface. We configured it, and actually, we're not done yet. I'm sorry. We configured it, and now we need to configure everything else, all the other. So my IP route, right? My route to get to the 172.31.1.196/30, which is 255, 255, 255.252. So the first 30 bits going from left to right are dedicated to the network portion of the address. That is going to be our subnet mask. And so now and they wanted recursives for all of this, right? Yeah, they certainly did. So the next hop IP will be 172.31.1.193. Again, the entries will look very similar because the next hop IP is the only IP it could be. It's got to be that interface on router 2 because that is the network to which we're directly connected. All right, and then the last entry, which I'll pull this back here, is 172.31. And I needed a little more room. 172.31.1. Whoops, sorry, 172.31.1.128. Oops, I'll get the subnet mask in here. And what is a /26? Well, it's 255.255. We know the first 24, right? 255, 255, 255 dot, and then the next 2 bits have been borrowed to be network bits, in addition to some other bits that were borrowed along the way. But the next 2 are also going to be borrowed because we've got 24 bits so far. I need 2 more. So the first high order bit has a value of 128, followed by 64, which gives me 192. So that would be the subnet mask. And if you look in the lower right-hand corner, we should see that we're going to jump to 30 points, I hope. There we go. We're getting 10 for each of these guys. So there are my 3 recursive static routes. Do show IP route. Let's see what it looks like. Because in every instance, yes, router 1 now knows that's how I get to this network. Here's my static route to get to that network. Here's my static route to get to this network. However, in all three cases, all router 1 knows is the next hop IP. Not going to be good enough. He has to know the outgoing interface next. So that's why there are 2 lookups that take place. And where are we at here? I think that is it. So test connectivity to the R2 LAN. Ping the IP addresses of PC2 and PC3. I'm assuming they want us to do that from from PC1. And again, it's not going to work because we have half of the equation solved. Now, what do we get here? Yeah, does it say destination host unreachable? Is router 1 telling me, dude, I have no clue how to get to that network? No, he is not. Now what's happening is the request is timing out. So the request, the ping packet, has made it beyond router 1, and it's simply that we are not receiving an ICMP reply packet back. That our request has gone out there, we've waited, and nothing has come back. So that request has timed out. So again, half of the equation is done so far, and I guess for completeness here, we'll do 172.31.0.254, and we're going to see the exact same thing. Because router 1 knows, yeah, I send it to router 2. The problem is that we're not, the traffic can't make it, the replies cannot find their way back. All right. So, why were you unsuccessful? We're unsuccessful because the traffic doesn't know how to find its way back. So let's try to resolve this. So configure directly attached static routes on router 2. So how does a directly attached static route differ from a recursive static route? It differs in that the traffic will be sent out with a single lookup, right? Configure a directly attached static route from R2 to every network not directly connected. So router 2 is we're going to do 2 directly connected static routes. It should be pointing down here. One for the network here on PC1's LAN and one for the LAN behind router 3. So let's get onto router 2, and I guess this is our first excursion here onto router 2, and so I'll block router 2's LAN. We don't need that information. And again, we go from user exec as evidenced by the greater than sign with the enable command into privilege exec mode, which is the pound sign or the hash sign. So I say show IP route, and what does 2 know about? He knows about 3 networks. He knows about the 3 directly connected networks, and that is it. So we now need to help router 2. So we're going to get into global config with configure terminal. I'm going to say, and again, remember in English, my IP route to get to the 172.31.1.0/25. So there's the first 24 bits, and then we know that the next most of the high order bit there in the 4th octet is a value of 128. So in order to get to that network, and remember, I'm indicating the whole network. So if there were 10 PCs over here, this routing statement that I'm putting in covers them all. It covers all bases for any host on that network segment. Now, if you're wondering, could you put in a static route that only goes to PC1? Absolutely you could. And in fact, I'll show you how to do that. So, because maybe that question is popping up in your head right now that, well, yeah, you can get to the whole network and that's all great, but what if I only want to go to one PC? How does that work? So, my IP route to get to the 172.31.1.0/25 is out the serial 000 interface. Now, this message, I'm drawing a blank here. I believe Nick sent me an email this morning, and he was concerned. He saw this message, and he thought this is an error, that I'm not doing it right. It's broken, right? But you'll notice, you look down here in the lower right, and what do we see? Yeah, I got 40 out of 60. So I just picked up an additional 10 points. Now, that is not an error message. That is simply a warning, right? It's telling you that by using the outgoing interface, what you may have happen on a multi-access segment, and I'm going to draw a very simple one of these out to explain this to you, that if it's not a point-to-point interface, and these between the routers, all interfaces between router 1 and router 2 and router 3 and router 2, those are point-to-point. There is only one other thing on the other end. That's how you define point-to-point. So in other words, I can't get anything else on this link. It is literally going to be these two interfaces, and that's it. So it is point to point. That's it, right? And that's point to point. And so to pull the error message back up here, and what was I on, router 2? It says, if not a point-to-point interface may impact performance. So you might be asking yourself, well, why would that impact performance? Well, let's do this. Let's say I've got a 48 port switch here. Whoops. Switch number 2. I'm just throwing a switch in there. And you got all these ports on this switch, right? And let's say that we've got all these routers connected into this switch. And this is something that is not unreasonable to see, right? So we've got all of these routers, router 1, router 2, router 3, router 4, router 5, router 6, and there's a network segment over here behind router 4. And we're going to say it's the 192.168.1.0/24. Keep it simple, right? So I've got a PC over here behind router 1, and he wants to get over there to the 192.168.1.0. This is a broadcast segment, multi-access segment here, right? This is a switch. Let's just say it's all one big VLAN. So if on router 1, I create the route just like we did right here, and I tell it, yeah, just go to the gig interface right there, right? So I say IP route, and what would that routing statement look like, right? So here's a bonus question. It would be IP route. So my IP route to get to the 192.168.1.0, and now I'm regretting doing a /24 because I have to write out all these 255s, .0 is out gigabit Ethernet. Boy, it's a terrible G. Gigabit Ethernet 0, let's just say it's 00, right? So what's the problem here? Because it's not point to point. So router 1 might have to ARP or send an address resolution protocol packet trying to find the next hop IP address, right? So he may have to ARP and get the information that's required to maneuver through this multi-access, right, this big broadcast domain here with lots of routers plugged in, because it's not clear in this environment where the next hop is going to be. So an ARP packet may get sent, and that is the performance impact that they're concerned about. And if you've got tons of those requests going out, and we're talking about millions of packets floating back and forth, you could see a severe performance impact, but not an issue, right? Because we are point to point. And again, it is not an error. It is simply a warning. Okay. So we're on router 2, we're in global config, we did the first statement, now let's put our next statement in here, which, and I'll pull all of this back, we need to get to the 172.31.1.1.128, and the subnet mask, we already did this guy, is 192. Remember, 128 plus 64, because we're borrowing 2 bits out of that 4th octet, is going to be 192. And then again, directly connected, out the serial interface, and on cue, we get the point-to-point interface performance impact warning, but it's not a concern. These are point-to-point interfaces, so no big deal. And let's see here. So that's how the directly attached static route differs from the recursive. It's a single, it uses the interface instead of the next hop IP. And It does a single lookup. Configure, we did that. Which command only displays connected networks? Do show IP route connected, right? So there are all of my directly connected networks. Which command displays only the static routes? And again, we saw this, do show IP route static. There's my two statics, right? My two directly connected statics. And you know what? I just realized who caught it. What's wrong with those entries? Or what's wrong with one of those entries? Yeah, if you're looking at that saying, yeah, Travis, you just sent all the traffic for the PC3, and I just realized this, that statement right there is wrong. So I'm going to remove it by saying no IP route. And then I'm going to pull it right back up, and we're going to say, and I hope is it 001? It is 001. So what I did there was I made a mistake. I'm so wrapped up in the conversation that I put the wrong outgoing interface there. We still get the same performance warning, but that's okay, because now the traffic's actually going to get to where it was supposed to go. It's going to go out the right point-to-point interface. And when viewing the entire routing table, how can you distinguish between a directly attached static route and a directly connected network? Well, let's take a look. Do show IP route. So, a directly attached static route is here. And one way you can tell the difference between a directly connected static route and a directly connected network is that the directly connected network will have an accompanying local entry. The statics do not have that, right? So that's one way. And then you can also tell by the S for static, C for connected, and L for local. And if we go up just a little bit further here, there's a legend. So L is local, C is directly connected, and S is static. Convenient that those are the three that are there, right? So we see those. And now let's test connectivity here. Or wait a second, where are we at? When viewing is, okay. So configure a default route on router 3. How does the default route differ from a regular static route? Well, let's create it and let's talk about it. And again, this is a very valid use case for a default static route on router 3 because PC3 right here, how many ways can PC3 get to anything beyond R3, beyond router 3? One. There's a single way, right? It's this link right here. That's it. So on router 3, and we could have done this on router 1. We could have done this on router 1, but they wanted us to do the recursive setup. So we're in user exec, and the enable command gets us into privilege exec. We get into global config with the configure terminal command, and I'm going to say my IP route to simply the default network, right? Or the default gateway. Think of it as the default gateway, and this is why it's referred to. You'll hear this referred to as the quad zeros. It's just 0, 0, 0, 0, 0, 0, 0, 0, right? And that basically says my IP route to get to everything that I don't have a directly connected entry for in this case, right? Because we don't have any other routing protocols running. So again, my route to get to all IP networks, and that's what those two sets of quad zeros represent, is all IP networks, right? And I'm just going to go out the serial 0, 0, whoops, 0, 0, 0, 0 interface. And let me make sure that they configure a default route. Not directly connected. Okay, yep. So we'll just say 0, 0, 0. And of course, we get that, that warning message there. Not an error, it's a warning message. And I'm paying very careful attention over here. It didn't like the fact that we did it in a directly connected fashion. It looks like it might want the next hop IP, which would be 172.31.1. And actually, let me come back and get the no out of here. 172.31.1. And router 2 is 197. Was it looking for that? And it was. So I didn't see them say next hop. It's possible that I missed it. I'm squinting. I'm leaning in here trying to see how does a default route differ from static route. Configure a default route network is not directly is reachable. So how is a static route displayed in the routing table? We've already seen this. Do show IP route static. And there is my static default route that refers to a next hop IP address. Okay, so Packet Tracer does not currently support, oh, it doesn't support, so that's okay though, that's okay. So Packet Tracer doesn't currently support configuring a fully specified route. Well, it's a good thing I just happen to have a 1941 router here on hot standby for just this case. So do show, and I don't think it's configured with anything here. I'm sorry, do show IP interface brief I wanted to see. Do show IP interface brief. What interfaces do we have? Yeah, so is it going to let me do this? Let me do this. Interface gigs, and I think I have, hold on one second here. Let me get this, let me clean this up a little bit. Okay, so yeah, configure, replace, flash, and you don't need to know how to do this. Sec baseline, is that what I wanted? Yeah, I think I thought, oh, base config, that's what I want. I want the base config, sorry. So I basically have, all I'm doing right here is I'm loading on top, I'm just basically, I have a little configuration saved off called base config, and it throws some basic IP addressing on here and stuff like that. And look, it gives the host name and everything. So we'll not show IP route, show IP interface brief. So that's what we look like now, right? And there's that loopback address, Lauren, if you're watching. Okay, that's how you would see the loopback, and this is you create that with, you manually create it. So now we've got the gig 00 interface, and it's in the 10.0.0.11, that's the IP address, and the network is 10.0.0.0/24. So how do we configure a fully specified, we say IP route, and let's suspend reality here. I'm trying to get to the 192.168.1.0/24, right? We'll keep it simple. So my IP route to get to that network is going to be, and I'm trying to remember the order here. I think it's gig 00. I can check it. Yeah, and then we put in the IP. And this is how you would fully specify it. So let's say that the next hop, right? The next hop is going to be 10.0.0.12, right? It's a router that's in this multi-access segment. That is a fully qualified static route. And it's fully qualified because we've taken the recursive approach and combined it with the next hop IP approach. Or I'm sorry, the outgoing interface approach, right? So we did the directly connected approach, I should say, and the recursive approach, and we combined them for a fully qualified. Now, a quick caveat is it is very important to understand the differences between these three types of static routes. However, on current Cisco iOS software, it doesn't matter anymore. You can put it in as directly connected. You could put it in as a next hop recursive entry that the iOS software on the current routers is smart enough to piece together what it needs to know so that it doesn't do two routing table lookups. But you definitely need to understand this concept and need to understand how that works. All right, explain a fully specified route. We did. It combines the best of the directly connected and the recursive. Which command provides a fully specified static route? We ran that command on a real Cisco router. Write a fully specified route from R3 to the network between R2 and R1. Do not configure the route, just calculate it. Don't configure it. Well, we've got the 60 out of 60. We're going to configure it. So here's how you would do it. I'm going to say my IP route to get to the network 172.1.192/30.255.252 because we're borrowing 6 of those 8 bits in that last octet. Is going to be out serial 000, and the next hop IP is 172.31.1.197. Yes, 197. So that would be, and it didn't like that, and oh, I apologize. Yeah, we can't configure it because Packet Tracer doesn't support it. I had forgotten that statement already. So, but that is the command that you would run, and we just saw that on the real Cisco router. So write a fully specified static route from R3 to the R1 LAN. Well, it would be that right there, except it would just be that the network would be different. It would be, and I'm going to have to drag this window out of the way, 172.31.1.0, and then 255, 128. And that is what, I'm sorry, yeah, that is what the entry would be on router 3. All right, now the last thing I'm going to show you, and I'll, whoops, sorry. Oh, we might as well leave it here. So we're going to configure a static route on router 3, and this is referred to as a host route. Because if you were wondering, how do you do it if I just wanted it to go to one PC? Can I do that? You certainly can. So my IP route to get to the 172.31.0.254, you'll notice I don't put the subnet here. I'm putting the exact IP address of the PC here. And if it's the exact IP, then every single bit in the subnet mask is accounted for. It's all 255s. And then I could simply say, go out the serial 000 interface. And that is what's referred to as a host route, because it is a static route that goes to a single host. So in other words, if there were other things, other PCs that were out here, right? And we're going to say that that's the only route that we have to get to this network from router 3. PC3 would be able to get here. That would work great. So we'll put a check. But to get to that PC right there, it would not work. This is not going to work because we would only have the host route, right? Now, if I leave both routes in there, the host route that we had on router 3 and the default route, it's going to work just the same. Now we just have redundancy, right? We have a second route to get to that PC in addition to the default route. All right, well, this is going to wrap up Packet Tracer Activity 2.2.2.4, where we took a look at IPv4 static and default routes, and we went deep dive. We did a recursive route, and we talked about what that is and why it's recursive. We did a directly connected static route. We talked about what the differences are and why you get that nice little warning message that there may be a performance hit. Not in point-to-point scenarios, but in multi-access scenarios, you could have a performance hit. And then we did the default static route, which, when there's only one way out of the segment that you're coming from, PC3, can only get to the PC1 and 2 out one interface on router 3. We might as well use a static default route. All right, guys, thanks for watching, and I will talk with you soon.